Right, the number of sandwiches, S, is increasing with respect to workers, W, at a rate proportional to the number of workers in the kitchen. Assuming that there are 9 workers and the rate of change of the number of sandwiches is 9.5 sandwiches per worker at that time, what is a differential equation to model the situation? Now, we need to remember, well, what do we do in the first place? We want to see, is there a rate that is being talked about? And I can see here that at the beginning it says that the number of sandwiches is increasing with respect to workers. And so we know that our sandwiches, ds, or change in sandwiches, is changing with respect to the change in workers, dw. And so we can set ds over dw equal to something, and let's keep reading. At a rate proportional to, not inversely proportional, just proportional, which means that this is a direct proportional relationship, which means we have k times something, to what part? The number of workers in the kitchen. Remember, workers is W. It's just that number, so K times W. All right, what do we have to do next? Well, what we have to do next is we have to consider, well, what is K? How could we figure that out? The next part of the question gives us that information. We see that when there are 9 workers, the number of the rate of change of the sandwiches is 9.5 sandwiches per worker. That 9.5 represents our dsdw, the rate of change of the number of sandwiches based on the number of workers, and then the number of workers gives us w. So we can replace that in our equation here. We can say that 9.5 equals k times 9. Now what do? We just divide both sides by 9 to get k by itself, and we find that k approximately equals, let me get my calculator, though really I should 9.5 divided by 9 is 1.055555, so 1.056, about. And so, when they're asking for the final part, which is, what is a differential equation to model this situation, we take our k and we plug it straight back into that equation we already made. So we get ds dw is equal to, what do we say k is? 1.056 w. And that, my friends, is our differential equation.